This video is part B for section 3.4. So this is what the beginning of this set of notes looks like. And we just barely finished number 8 on part A video. I think I've sufficiently finished up that problem. We had this multiplicity of 2 here, which means it bounced here, and multiplicity here 1, which means this goes straight through. Degree is 3, your leading coefficient is -1, which means your arrows go like this. So there they are. All right, so then we'll move on to number 9. All right, so again, we're going to start off by writing down our list of possible rational zeros, which are just going to be the factors of 20. So that would be all right, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. So I'll start with 1 in the box like I always do. And then my coefficients, I've got 1, -2, -15, -4, and 20. So 1, 1, -1, -1, -16, -16, -20, -20, and 0. Yay, it worked. So now we know that 1 is a 0 of the polynomial. Okay, so in this case, the original polynomial is a degree 4. Okay, so that means that this here would be a polynomial of degree 3. So in general, we can't factor polynomials that have a degree of 3. I mean, in some special cases we can, but in most cases we can't. In this case, we would not be able to factor this if we filled in our x's, okay? So let's go ahead and write down what we have so far. So f of x equals x minus 1 and then here we would fill in this stuff here. So that would be, you know, here's your x to the third minus 1x squared minus 16x. So x to the third minus x squared minus 16x minus 20. All right, so we wouldn't be able to factor that third degree polynomial right there. So what we can do then in that case is go ahead and continue our synthetic division process till we find another 0. Okay, now in this case we got lucky and we got it on the first try. Okay, so we don't know yet what the multiplicity of this 0 is, so we actually need to do this again, but we're just going to use the coefficients from this polynomial. So basically we're going to bring these numbers down. Okay, so we're going to bring down these coefficients. 1, -1, -16, -20. And we're going to put 1 back in the box again. Okay, now if there were some zeros that we had already eliminated, like if 1 did not work, we would not try it again. Okay, so let's say if 1 did not work, but -1 did. We would not need to try 1 again, but we would need to try -1 again. Okay, so whichever one was the one that worked, we need to try that one again, not the ones that didn't work, and then continue on from there. Okay. Okay, so 1, 1, 0, 0, -16, -16, -36. So that's not equal to 0. So it's not going to be a 0 of this polynomial over here. So now we know that the multiplicity of that 0 is only 1, okay? Okay, and then we can move on to -1 in the box. And again, we're going to use these coefficients here. 1, -1, -16, -20. 1, all right, -1, -2, 2, -14, +14, -6, which is not equal to 0. So -1 is not a 0 of the polynomial. So let's move on to +2 in the box. 1, -1, -16, -20. 1, 2, 1, 2, -14, -28, -48, which is not equal to 0. So +2 is not a 0. We'll move on to -2 in the box. 1, -1, -16, -20. 1, -2, -3, +6, -10, +20, and 0. So now we know that -2 is another 0 of the polynomial. All right, so now we can continue the factoring. So we know we have x minus 1. Then we know we have x minus -2, which is, in other words, x plus 2. Then what we have left is x squared minus 3x minus 10. All right, and then this part is pretty easy. We can just factor that. That would be x minus 5 times x plus 2. So we have f of x is equal to x minus 1 times x plus 2 times x minus 5 times another x plus 2. So I see I've got two of these x plus 2's. So I'm going to write that as x plus 2 squared. Okay, and the order that I write these factors in doesn't matter. So I've got x plus 2 squared times x minus 1 times x minus 5. So now I know that the multiplicity of the 0 at -2 is 2. And I know now that I have a final 0 at 5 with a multiplicity of 1. All right, and just from looking at my original function, I know that the degree is 4, which also matches up to the sum of my multiplicities over here. And my leading coefficient is 1, which is positive. So my arrows are both going to point up. So let me go ahead and plot my zeros on the graph. Okie dokie, so this one's going to bounce and these are going straight through. And both arrows are up. Alrighty, and there's my graph. That's it for that one. Okay. Alrighty. Number 10. Alright, same type of deal. So first I'm going to list my possible rational zeros, which is going to be the factors of 10. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. All right, and then I'll just start throwing them in the box. So let's put the 1 in the box. And my coefficients, I've got 1, 5, negative 3, negative 17, negative 10, 1, 1, 6, 6, 3, 3, negative 14, negative 14, negative 24, not equal to 0. So 1 didn't work. Next, you're going to put negative 1 in the box. 1, 5, negative 3, negative 17, negative 10. All right, 1, negative 1, 4, negative 4, negative 7, positive 7, negative 10, positive 10, and 0. So now I know negative 1 is a 0. Okay, so I'm going to go ahead and start writing down my factored form of the function down here. So I know f of x equals x minus negative 1, which is really x plus 1. And what I have left there is, that's going to be x to the third, x squared. So x to the third plus 4x squared minus 7x minus 10. All right, so I already know that 1 was not a 0 of my original function, which means that it can't be a 0 of this either. So I don't need to do 1 again, but I do need to do negative 1 again. Okay, so negative 1 is going to go back in the box, but I'm going to bring down these coefficients here. One, negative 1, 3, negative 3, negative 10, positive 10, and 0. And it did work again. Okay, so here we go. That's x squared, and that's x. So x squared plus 3x minus 10. All right, so that part should be pretty easy to factor. It's going to be x minus 2 times x plus 5. And so this here, we can write that as x plus 1 squared. All right, so that's my factored form of the function. So now I know that the multiplicity of the 0 at negative 1 is 2. Now I know I also have a 0 at 2 with a multiplicity of 1 and a 0 at negative 5 with a multiplicity of 1. All right, and just from looking at my original function, I know that my degree is 4 and my leading coefficient is 1, which means both arrows are up. That degree also equates to the sum of these multiplicities, so that's a good sign. So I'm going to go ahead and plot my zeros. All right, so straight, bounce, straight. Both arrows are up. There's my graph. Okay. Okay. All right. Next, we are going to look at the graph and write down the polynomial from that. Okay. So I can see the zeros. I just don't know what my leading coefficient is yet. So I'm just going to put an A for my leading coefficient right now. So I've got a zeros at -6, +5, and +7. So that means I'm going to have x plus 6 times x minus 5 times x minus 7. Okay. Then I can plug in 0 for x and 105 for y, or in other words, f of x, to solve for a. So 105 equals a times 0 plus 6 times 0 minus 5 times 0 minus 7. Okay. So the negatives will, so it's basically 6 times -5 times -7. The negatives would cancel out. Let's see. So 6 times 5 would be 30. 30 times 7 would be 210. So this is going to be 210a. And then I just need to divide both sides by 210. Okay, let's see. I think that 35 goes into both of those to reduce the fraction. Because 35 times 3 would be 105. So 35 would go in there 3 times. And then for 210, 35 would go in there 6 times. Oh, okay. 105 actually goes into 210 2 times. That's 1/2. That would have been a lot easier to just notice that ahead of time. So a is 1/2. Okay. So f of x equals 1/2 times x plus 6 times x minus 5 times x minus 7. Okay? And hopefully they won't make you FOIL it out, but if they do, you know how to FOIL. Okay? You're supposed to anyway. If you don't, just search for a video on foiling. I have one for my 0342 class that I can send you. It's 13.3, 13.4 is on foiling. Okie doke. It'll teach you exactly how to do that. Let's see. Number 12. All right. And you can also just check some things on here, like, for example, you know, you've got a degree of 3 and a positive leading coefficient. So that makes sense with how it looks and everything. You got 2 turning points. It's a degree of 3. All right, number 12. Okay. And so what it says is it's saying find the polynomial of least degree. Okay, so don't throw in any additional x's, just... All right. So in this case, let's see, f of x equals, again, I'm going to put a for the leading coefficient for right now. And then I have a 0 at -3 and I have a 0 at +3. But from the looks of the graph, I can see that they both have to have an even multiplicity. And so since we're looking at the least possible degree, I'm just going to go with 2 as the multiplicity for each of those. X minus 3 squared, x plus 3 squared. Okay? And then we can plug in 0 for x and negative 81 for y, which is the same as f of x. So negative 81 equals a times 0 minus 3 squared times 0 plus 3 squared. Okay. So negative 3 squared is 9. Positive 3 squared is 9. 9 times 9 is 81. So basically that's 81a. And then you just divide both sides by 81. So negative 1 equals a. So f of x equals negative, I don't really need to write the 1, x minus 3 squared, x plus 3 squared. Okay. And finally, we have the intermediate value theorem. Okay. It says, suppose that a and b are real numbers such that a is less than b and f of x is continuous on the open interval from a to b. If f of a and f of b have opposite signs, so meaning one of them is positive and one of them is negative, then f of x has a 0 between a and b. Okay, so what they're saying basically is like, if you have a function and you know that you have a point where one of your points has a positive function value, so it's above the x-axis, and one of them has a negative function value, so it's below the x-axis, what it's saying, assuming that's a continuous function, well, it has to have a 0 in between a and b. So in other words, it has to actually cross the x-axis at some point in between a and b, is what it's saying. Okay, so the question then, number 13, does f of x have a 0 between 1 and 2? Why or why not? Okay, so we just need to evaluate f of 1, evaluate f of 2, and see if they have opposite signs. And if they do, then it has to cross the x-axis somewhere in between there. Okay. So f of 1, 4 times 1 squared, minus 2 times 1, minus 6. So that's 4 minus 2 minus 6. So that's negative 4. So f of 1 equals negative 4. And then let's evaluate f of 2. So 4 times 2 squared, minus 2 times 2, minus 6. So that's going to be 2 squared is 4. 4 times 4 is 16. Minus 4 minus 6. So f of 2 is positive 6. All right, so the answer to their question is yes, because f of 1 is less than 0 and f of 2 is greater than 0. So in other words, they have opposite signs. This one's negative, that one's positive. All right. And that's it.